Hi and Assalamualaikum. My name is Nurshafika binti Khairuddin. Today I would like to present my assignment for the digital communication course entitled QPSK of FDM system using MATLAB Simulink. This project focuses on understanding how OFDM communication works together with QPSK modulation and how noise affect the quality of transmitted signal in a digital communication system. First, I would like to explain the objective of the assignment. The first objective is to construct and simulate a complete QPSK or FDM communication system using MATLAB Simulink. The second objective is to observe how OFDM multiplexes data into multiple subcarrier for efficient transmission. Next, this experiment also investigates how Gaussian noise and AWGN channel degrade signal quality. Finally, the project aims to identify the signal-to-noise ratio or SNR required for reliable and error-free communication. Okay, for this slide, show the Simulink model of the QPSK or FDM system using a Gaussian noise generator. In this model, random binary data is first generated and then modulated using QPSK modulation. After that, the FDM block transmits the data through multiple orthogonal subcarrier. Then Gaussian noise is added into the channel to simulate interference that normally exists in real communication system. At the receiver side, the signal is demodulated and analyzed using the constellation diagram and Bert calculation. This slide presents the simulation parameter used for the QPSK or FDM system. For the experiment, I used a MRE number of 4 for QPSK modulation and a sample time of 1e-6. I also used a random 6 value of 10 so that the simulation result remains consistent every time the system is executed. These parameters are important because they influence the performance, accuracy, and reliability of the communication system. Okay, for this slide, show the constellation diagram of the QPSK or FDM signal under different noise conditions. From the diagram, we can see that the constellation points become scattered when noise is added into the system. The yellow dot move away from their ideal position due to interference caused by the Gaussian noise. The scattering made it difficult for the receiver to correctly detect the transmitted symbol, which is increase the bit error rate or BER. Therefore, the result clearly show that noise significantly affects signal quality and communication accuracy. Okay, next, the slide show the Simulink model of the QPSK or FDM system using an AWGN channel block. AWGN stands for Adaptive White Gaussian Noise. Compared to the previous Gaussian noise generator, the AWGN channel provides a more realistic communication channel model commonly used in digital communication analysis. The purpose of this part is to study how different SNR value affect system performance and signal quality. The slide presents the simulation parameter and AWGN channel configuration with SNR value ranging from 20 dB to 50 dB. The signal-to-noise ratio or SNR represents the strength of the signal compared to the noise. When the SNR value increases, the signal becomes clearer and less affected by noise. This allows us to analyze how system performance changes under different channel conditions. This slide shows the constellation diagram when the SNR is set to 20 dB. At this level, some noise is still present in the communication channel. As a result, the constellation points are slightly scattered and not perfectly grouped together. Although the receiver can still recover the data, some bit errors may occur due to the noise interference. And on the above, the constellation diagram when the SNR is increased to 50 dB. Here, the constellation points are very close together and clearly organized around their ideal position. This indicated that the signal is much stronger than the noise, resulting in very accurate signal detection. At this high SNR value, the communication system achieves minimal error and much better reliability. To conclude, this experiment successfully demonstrate the implementation of a QPSK or FDM communication system using MATLAB Simulink. The results shown that noise caused the constellation point to scatter, which increased the bit error rate and reduced communication accuracy. This experiment also proved the system performance highly depends on the signal to noise ratio. At this high SNR value of 50 dB, the system achieved very reliability communication with almost no transmission error. Overall, this assignment helped me better understanding on QPSK modulation or FDM transmission, the impact of noise, and the importance of maintaining a high SNR in digital communication system. That's all from me. Thank you.